Hello, this is a continuation of the story of complex roots of 1. So, last example worked out was degree 3. Let's pick it up. The general equation we're solving is some complex number to the power n is equal to 1, and the next in line is when n is equal to 4. So we are looking at degree 4 roots of 1, their position on complex plane at the intersections of the coordinate axis with unit circle. Well, they have to sit on the unit circle and they have to divide it into 4 equal parts, and the first corner is at 1, so the next one should be at I, next after at -1, and then -I. We have a generic form of solutions, conveniently written in trigonometric form, 2 pi I over n taken k times. So that is a compact notation for cos of 2 pi over n k times plus I sine of 2 pi k over n. And for n being 4, we have these 4 roots, and then we can write them as using this trigonometric notation or this compact order notation. So say I will be e to the 2 pi I over 4 simply is pi I over 2, -1 is e to the just pi I, and -I is e to the 3 pi I over 2. And that is very straightforward for n being 4. Let's look at the next case, n being 5. So we're looking at degree 5 roots. There should be 5 of them, dividing the circle into 5 equal parts, starting at this position 1. So the next 2 will be here, and there will be 2 more on the other side of the y-axis. So that is y attempts on a regular pentagon. So here is epsilon 1, epsilon 2 is here, epsilon 3, epsilon 4, and this is epsilon 0, which is as good as epsilon 5th. Let's just abbreviate it to epsilon, because this is nothing but epsilon squared, and this is nothing but epsilon cubed, and this is epsilon to the 4th power, and this is epsilon 5th power 1. At the same time, we could say that this being a mirror image with respect to x-axis of epsilon 2 is its inverse, or its conjugate to be precise, but it's the same as its inverse. So that is negative to 2nd power, and that is negative 1st power of epsilon, because again they are symmetrically placed with respect to the x-axis. So the task is to find the coordinates of epsilon, for example. So that would be finding really the answers for cos of 2 pi over 5 and sine of 2 pi over 5. But what happens is we can find a closed radical expression for them. So to get that, let's start with some simple algebra. What do we know about epsilon? Well, it is a solution by design of this equation, something to the 5th power -1 equals 0. But we know that epsilon itself is not 1. It's not 1, so we can, looking at geometric series factorization of this difference into the product as follows. We can be sure that since epsilon is not 1, this combination of powers of epsilon is 0. So let's start with this combination, but let's rewrite it immediately because of these simple rewriting rules. So the cube is as good as negative 2nd power, and the 4th is the same as the negative 1st power. So let's just write them with these negative versions. And the reason for doing that, the ground reason is, since we're interested in this number twice is equal to this position, well, let me call it R. This position R is equal to, twice is equal to epsilon plus epsilon inverse. Because epsilon plus epsilon inverse will be a real number, will be twice the real part of epsilon, twice R. So we are to find epsilon plus epsilon inverse. Let's call it just a single name alpha. And we have it here, and we also have this expression in terms of epsilons, which is not immediately related to alpha, but let's look how we can link it with alpha squared. So let's compute alpha squared. Let's take this definition of alpha and square it. So we'll have epsilon squared, we'll have epsilon negative squared, and we'll have twice the product. And the product of the two is 1, so we have just extra 2. So we have this, and we have it here as well, and we can link it with alpha squared by just putting 2 on the other side. So epsilon alpha squared minus 2 is epsilon squared plus epsilon negative squared. So let's put it all in use here. We have epsilon inverse on epsilon, which is just alpha. We have this, which is alpha squared plus 2. Then alpha coming from epsilon's first power and negative first, and then this extra 1. So when we combine them all, we will have alpha squared, then alpha, and then negative 1 because of this cancellation. And that is all to be 0. And that is telling us what alpha should be. So 2 roots this equation will have. Let's just find them. The standard solution method is to take this coefficient with negative sign, and then we'll add or subtract the square root of what's called the discriminant, and then divide it by 2. And the discriminant is the square of this coefficient, 1 minus 4 times the product of this coefficient, so it's negative 1. All in all, it is negative 1 plus or minus the square root of 5 over 2. And these are all roots of this equation, but we're interested in a positive number here. Definitely it is going to be a positive number. So we have to choose the positive root because, yeah, one root is positive, the other is negative. So our alpha is this positive root, and it is equal to negative 1 plus the square root of 5 over 2. Oh, we are ready to say what r is, what the cos of 2 pi over 5 is. That is half alpha, that is half this number, that is negative 1 plus the square root of 5 over 4. So that is our first answer, that is the position here. The y coordinate is called the sine of 2 pi over 5, and we can use it in Pythagoras, write it as 1 minus cos of 2 pi over 5 squared. So that can be done, can be computed just by using already obtained answer for cos. So we just have to take the square of this, will be 16 in the denominator, and then there will be the square of this, which will give us 1 for the square of negative 1, 5 for the square of this, and then twice the product. So 1 and 5 will give us 6 in total, and twice the product will come with minus sign. That will be this. That can be simplified. 2 can be cancelled throughout. So let's do that before continuing with series computation. So we have 3 without square root of 5 over 8. Now we can do common denominator under the square root. So we have 8 without 3. It will be 5. And then we have with minus sign and minus again negative 5. So it will be positive square root of 5. And that is the answer for the sign. And we are done with determining the position of epsilon. So determine the position of epsilon inverse is easy. We just need to choose the negative square root for the sign. Determine the positions of the two is a good exercise, which I'll leave to you. See you later.